Good morning, my sunshines. Happy Tuesday. Today we're going to be talking about systems of equations. And you're thinking to yourself, well, what the heck is a system? Well, a system is when we have more than one equation at a time that we're looking at. Okay? So it could be two equations, three equations, four equations, as long as it's more than one. The solution to a system is an ordered pair. Remember, ordered pairs come in the form xy. That is true for both equations. So let's take a look at this example. This will be a question you would get. So notice I have my system here. The system is made up of two or more equations. So I have 2x plus 14y equals 20, and I have x plus 3y equals 19. They want to know if the ordered pair 3, 1 is a solution to that equation. So how do we figure this out? Well, I rewrote this on another board, and let's take a look. So first thing we're going to do is we're going to plug in the ordered pair that's in the form xy into each equation and see if it makes each equation true. So let's take a look. So I wrote the same problem that was on the other board. I had 2x plus 14y equals 20, and I had x plus 3y equals 19, and they want to know if 3, 1 is a solution. So first thing I did is I wrote in my ordered pair, x comes before y in the alphabet, so it goes in alphabetical order for ordered pairs. So the 3 has to be my x, and the 1 has to be my y. Now, I'm rewriting the equation, but every time I see the x, I'm going to put a parenthesis and plug in or substitute the 3 where the x would have been. Notice the x disappears when I plug the 3 in. Then I take the y, which was the number 1, and I plug in 1 where the y would have been in the equation. Notice I put it in parentheses. Why do I put it in parentheses? Because there is a number or a coefficient attached to the variable. So I'm going to have to multiply that by the number that was in front of the x and the 14 that was in front of the y. So then I multiply. 2 times 3 is 6. 14 times 1 is 14. Does 6 plus 14 add up to the original equation's 20? Well, if I do the math, 6 plus 14 is 20. So I know that 3, 1 is true for the first equation. Is it true for the second equation? Now notice this time I'm plugging in 3 for x. I forgot to write it in blue, but I didn't put in parentheses because there was no coefficient attached to the x. So it's just 3 plus 3 times 1 equals 19. 3 I just brought down. What's 3 times 1? 3. Does 3 plus 3 add up to 19? No, 3 plus 3 adds up to 6. So this would be false. That means 3, 1 is not a solution to the second equation. So they asked me, is this ordered pair a solution to both? If it's not true for both equations, then you have to say it's not a solution because both aren't true. Okay, let's try another one. I know you guys are going to pick this up very easily. Hang tight. All right, this one says, is negative 1, 9 a solution to the system of equations? So here are my two equations. I have 14x plus 3y equals 13, and I have 7x plus 2y equals 11. So I take negative 1, 9, I label it x and y, and then I'm going to substitute that in. The negative 1's going to go in where the x is, and the 9's going to go where the y is. So notice I put it in parentheses, so I remember that I have to multiply it by the coefficient that was in front, okay? So I'm saying 14 times negative 1 instead of 14 times x. So that gives me negative 14. Bring down the plus side. 3 times 9 is 27. And then I rewrite the equals 13. Does negative 14 plus 27 equal 13? Well, it's the same as saying 27 minus 14, which is 13. So I know that's true. Now I'm going to try the second equation. 7 times negative 1 plus 2 times 9 equals 11. Is that true? 7 times negative 1 is negative 7. 2 times 9 is 18. Does it equal 11? Well, negative 7 plus 18 is the same as saying 18 minus 7, which does give me 11. So that's true. Since both are true, that means negative 1, 9 is a solution to this system. Okay, please watch the next video. I'm going to show you how to do today's IXL. I hope you're having a wonderful day. I sure do miss you guys.